the token that you guys need to use. Okay, so all right, so those are the tokens that for each of you. Okay, so let me just show you how to do that. You guys are able to go to know how to do the tokens, or very similar to the previous semester. Let me just give you this screen first. I'm just let me just sign out first from my net account. All right, can you see? Go to login, redeem seed token. Right, so Noel already, yeah. Kelvin doing currently have enter your email for your profile and then seed token and submit. Okay, let me know uh, once you are able to access the. Let me just go to login first. Oops. No. Okay, I got disconnected. Hmm. All right. How about you, Kelvin? So you should be able to see this advanced computer networks. Just view students first. All right. So ENSA, Enterprise Networking Security and Automation, as you can see here, right? Let me just, yeah, you see Enterprise Networking Security and Automation, ENSA for ACN, right? So this is the course content. Right, I think there's no changes in terms of the packet tracer, but as usual, you can go to resources, right? And then student resource and packet tracer resource, right? And there you can download your packet tracer, right? So I think there's no change. Let me just double check. Yes. Oh, sorry. This one is 8.1.0, 64-bit, right? So we need that for packet tracer exercise. Okay, redeem. Okay, so you guys please go to check uh, to go through here and see whether you're able to access. You need to check your email, right? Email address, and click on the link lah, right? The link will bring you to the what lah, to that login. Right, let me just all right. You guys can access, yeah? Can access. Noah can access. Kelvin, can you access?
Access.
Can I? All right. Okay, so in your Google Classroom, I've already uploaded our this week's practical, okay, lab practical. Obviously, the lab was meant for hardware lab, but I'm going to use the packet tracer for now, right? Download that, okay? And we'll discuss, go through the lab one, yeah?
Can use the packet tracer from last
Can,
semester.
I think no difference. 810 still the version, right? I'll just show you just in case you uninstall already. All right, so if you still have installed in your computer, then no problem. Just use it before, right? So we're going to implement this using packet tracer, lah, right? So basically, you're just going to be using two routers, two switches, and addresses that going to be creating here, right? And continue to here. Let's look at the objective, right? So first part, we just build a network and configure using our last time our configuration knowledge. Yeah. So it's configure basic device settings first, right? And then configure and verify IP version 4, yeah, and IP version 6 addressing on router 1 and 2. So you can see that they give both, right, the FE, all this being local address for IP version 6. And then part 3, we want to configure static and default routing for IP version 4. And then part 4, we configure IP version 6, right? Static and default routing for R1 and 2 as well. Right, so here's the background, right? So when you're selecting your routers, um, to make it realistic as possible, see whether you can use the router with the model 4221 and switch 2960, right? Okay, so it's just okay. So if you're a packet tracer, 4331 and 2960. Okay. Okay, so take note of this. This is actually what you need to use if you're using real hardware. Okay, but we just gonna apply on packet tracer, right? Okay, so just follow step by step when we're building the network that we see the topology up there, right? Just go through um, device name for router. I think we just follow topology. It says R1, so R1 lah, yeah, the host name, right? And then go to step 2 for each router. Okay, these ones are all you've already learned before. Just check back your previous exercises, so if you don't remember. Okay, right, and then we are continue configuring for the switch, right? And then after you configure both sets of devices, both routers and switches, go to part 2. We want to now we want to configure the addressing, right? Okay, so first of all, we enable the IP version 6 routing on both routers because we are going to create a dual stack router, okay, service. So that means you can route both IP version 4 and IP version 6 packets, yeah. Right. So all the interfaces you can see on the router, you will follow the addressing table to configure interface. So config terminal, then IP, then configure interface, sorry, IP interface, and so on. And then make sure you follow the addresses correctly lah. Huh? Copy paste also can because packet tracer quite easy for using packet tracer. right? Okay, so issue command to verify simply means I think show IP interface, right? You can see whether you have done the addressing properly. Set running config, right, for both routers. Now, um, I want to just remind that if you're in the lab, before you actually do all these things, right, you have to actually verify, or if you don't want to verify, you can just run the reset, um, steps lah, like deleting VLAN for switches, um, deleting the running config for both routers and switches, right? For the real hardware. Because for the real hardware, okay, once the students prior to your session probably do something, right? So need to delete. Okay, but for packet tracer, no problem lah. When you drag, you will be by default it will be reset to factory defaults lah, right? So just for lab environment, real lab environment, you need to make sure that when you start working on the switch and the router, you have basically reset the settings, right? Just in case the previous students they didn't do it, so there's leftover settings, right? So save your configuration, then you go to part three, right? And part three is the part where we've learned in our lecture how to configure and verify static and default routing for IP version 4. And later on, I think it's for IP version 6 as well. Right? So just follow the steps to do that. Okay. And then the part 4 is for IP version 6. Follow the steps as well. And that's it, right? Is it is it okay for you guys? It's straightforward actually again.
Okay.
Yeah, all right. So let you guys do first. Any question? I'm monitoring. So if you have any question, just message here, alert me. Right. So Noel and Kelvin, just continue first. Follow step by step. All right. Just want to say, obviously, if we are using packet tracer, everything is actually quite fast to do. All the cabling, perfect cables. So when you link it, it should work, right? But if we are doing this on a real, real network, real hardware, one of the issue, nothing to do with the networking stuff at all, but of course we have to consider this, is sometimes due to wear and tear and maybe um, some kind of accident, damage or whatever, the cable might be faulty, right? And it's very difficult by just looking at the cable whether it's an okay cable or faulty cable. So a lot of times students when they're doing this on real, if they happen, especially if cables has been used many times before, right? Sometimes they think that their configuration is there's something wrong, but in fact it could be the cable. So just to say that the differences between using real hardware and packet tracer is that you have to contend with a lot of other hardware issues, right? Hardware issues like what I say, previous configuration, you have to reset. Cables may be damaged. Hopefully the router and switches they're hardy, so not damaged too much. Sometimes plug in. Sometimes the cable becomes stretched, and then I don't know, some wires connection may be gone. You know, things like this lah. And also setting up the router switch, and in order for you to configure. Here is not shown. How do you configure router and switch? Right, because in a real hardware, you cannot simply click and the configuration comes out, right? So what you need to do is you have to plug in the console cable, right? Console cable into the computer, and then from the computer go to the intermediary device one by one, right? So you plug into router one, then you configure router one, okay? And then you swap over to router two, then configure router two. So how do you connect? You will use a software like a terminal emulator. The ones I saw use, I believe we will use also that is Pati. Pati is a free terminal software, right? So these are the extra steps that can delay, yeah, when students are working on real hardware, right? But I think when you're using packet tracer, you have no issues. You have no such similar issues. All right. So just to give you you know some idea about it. Okay.
Hi dear friends, welcome to TechAcad. In this video we are going to discuss CCNA version 7 packet tracer activity, configure IPv4 and IPv6 static and default routes. Hi friends, welcome to all. In this video we are going to solve this lab activity, configure IPv4 and IPv6 static and default routes. Now back to this lab activity. Here we can see the topology. We got two routers and two switches. Also we can see the addressing table. We have to configure IP. IPv4 as well as IPv6 addresses. We will go to the objectives. Part 1, build the network and configure basic device settings. Part 2, configure and verify IP and IPv6 addressing on R1 and R2. Part 3, configure and verify static and default routing for IPv4 on R1 and R2. Configure and verify static and default routing for IPv6 on R1 and R2. We will go to the scenario. Static and default routing are the simplest forms of network routing and configured manually. They are fixed, meaning that they do not change dynamically to meet changing network conditions. They are either valid and made available to the routing table or invalid and not made available to the routing table. Static routes have administrative distance of 1 by default. However, static and default routes can be configured with an administrator-defined administrative distance. This capability allows the administrator to put the static or default route in reserve and only make it available to the routing table when routes with low administrative distances, usually generated by dynamic routing protocols, are no longer valid. They are given a note. In this lab, we will configure static, default, and floating default routes for both IPv4 and IPv6, which may not reflect networking best practices. Okay. So the routers used with the CCNA hands-on labs are Cisco 4221 with the Cisco IOS XE release 16.9.4. The switches used in the labs are Cisco Catalyst 2960 series with the Cisco IOS release 15.2. So even we can use other routers or other switches also for this lab activity. Console cables or Ethernet cables, whatever needed to connect those devices. We will start the instructions. Part 1, build the network and configure basic device settings. In part 1, we will set up the network topology and configure basic settings on the PC host and switches. Step 1, cable the network as shown in the topology. Attach the devices as shown in the topology diagram and cable as necessary. So here we can see our topology. We will design this topology in our Cisco packets. In the note, it is specified to use 4221 router, but here we can see in this packet tracer, we have 4331 or 4321 series. So we will choose this router 4311 series. We need two routers. Click on this 4331 router. This is R1, and here we have R2. Then coming to switches, we will choose 2960 series. This is S1, and here we have S2. Now we will connect these devices. Coming to connections, first we will connect R1 and R2 using copper crossover from G0/0/0 to G0/R1 and R2 using copper crossover from G0/0/0 to G0/0/0 in R2. Now we will choose copper straight through, and we will connect R1 and S1 G0/0/1 to S1 FS0/5. Then from this R2 G0/0/1 to this S2 FS0/5. Now we have to connect these switches S1 and S2. Here we have to choose copper crossover FA0/4 S2 FA0/4. Just we can organize these devices. R4 S2/0/0 in R using copper crossover. From G0, we will connect these devices. Coming to connections, first we will connect R1 and R2 using copper crossover from G0/0/0 to G0/0/0 in R2. Now we will choose copper straight through, and we will connect R1 and S1 G0/0/1 to S1 FS0/5. Then from this R2 G0/0/1 to this S2 FS0/5. Now we have to connect these switches S1 and S2. Here we have to choose copper crossover FA0/4 S2 FA0/4. Just we can organize these devices. Okay, now it looks good. Okay, that's fine. Okay, we just designed this topology, and here we can see the specified loopbacks. In R1 we have loopback 1 and loopback 2. Then in R2 we can see loopback 1 and loopback 2. So these loopbacks we will add while configuring it. And no need to draw those diagrams here. Okay, now in step 2, configure basic settings for each router, that is R1 and R2. Assign a device name to the router. We can do that. These are all basic settings. You know, we have to give this command pass as the privileged encrypted password. Then next we have to set the password ACN class as the privileged encrypted. Coming to R1, enable secret class. Now we'll go to line VTY02 15 Cisco command here. Then shut down it. We will configure and verify the IPv4 and IPv6 addresses on R1 and R2. Neighbor explain, because we can see these ports are down, correct? R1 is connected to R2, but it is down. Then we can see R1 is connected to S1, and this link is also down. So obviously there will not be any result. We can see that R1 password is Cisco, enable password is class. Here we will give show CDP neighbors, and it's empty. We cannot see any neighbors, right? Same way we can verify in R2 also. Password class. show CDP, go to particles on R1 addresses for both, and here we will give conf t, short form of configure terminal, and here we can give IPv6 unicast dash routing. T shortcut routing. First, coming to R1, conf t, and here we will give IPv6. Unicast routing. Coming to R2, conf t, short form of configure terminal. And here we can give IPv6 unicast dash routing. Configure the IP address for all the interfaces according to the addressing table. Okay, we have to set the IP address. Here we can see our addressing table for R1 as well as R2. First of all, we will configure R1, and we will configure this interface G0/0/0, which is connecting to this router R2. Okay, coming to R1. We will go to this interface G0/0/0. And we will activate this interface. We have to give no shutdown. set the IP address, IPv4 address. Here we can see that. Just copy and paste, or you can type it. Then the subnet mask. Also, we have to configure IPv6 address. I will copy this IPv6 address and paste here. And make sure that there is no space in between this hex text or any characters. Then IPv6 address, because we have to configure the link local also. FE80:1 space link dash local. Then we will configure G0/0/. Then we will configure G0/0/. One. Exit and go to interface G0/0/1. No shutdown, we will activate it. Set the IPv4 address, IP address 192.168.1.1. Submit to mask. IP, the IPv6 address. Then we have to set the IP address. Set the IPv6 address. Then up the loopbacks. Exit and go to interface loopback. We can give local. Then we have to configure these loopbacks. Exit and go to interface loopback. We can give LO1. It's called loopback 1. Okay, it's up. Set the IP address. Here we can see that. Then submit to mask. Set the IPv6 address. We can remove this space. Also set IPv6 address FE80:1 as a link local. Exit and go to interface loopback 2. We will set the IP address. Okay. And we have to set this subnet mask. Here we can set the prefix they given /27. So here is the subnet mask. We have 27, 25, 26, 27. That means we borrowed 3 bits from the host portion. So we will get 224. Also, we will set IPv6 address. Loopback 2. Just I will copy and paste it. Or you can type it perfectly. Also, we will set IPv6 address FE80:1 as a link local. Copy run space start. Now we will configure R2. Here we can see the interface G0/0/0, which is connecting to this router R1. We will go to the interface G0/0/0. We can activate ignore shutdown command. IP address. I will copy this IP address. See G0/2 IP address. IPv6 assignments to the interfaces. Okay, coming to R1. So here we can see all the links are activated. Step 2, verify addressing. Issue the command to verify IPv4 assignments to the interfaces. Also issue the command to verify IPv6 assignments to the interfaces. Okay, coming to R1. Here we will give that show command, the show IP interface brief command. So that we can see the IP address we configured. This is IPv4. Now for IPv6, we have to give a show IPv6 interface brief. And here we can see all the IPv6 address we configured for the interfaces. Coming to R2. Show IP interface brief. Also we have a show IPv6 interface brief. G0/0/0, 0/0/1, and loopback 1 and loopback 2. Save your configuration. Save the running configuration to the startup configuration file on both routers. Yes, we done that already. Now in part Part 3. Configure and verify static and default routing for IPv4 on R1 and R2. In part 3, we will configure static and default routing on R1 and R2 to enable full connectivity between the routers using IPv4. Once again, the static routing being used here is not meant to represent best practice, but to assess your ability to complete the required configurations. Yeah, this is very important. Step 1. On R1, configure a static route to R2's loopback 1 network using R2's G0/0/1 address as the next hop address. Use the ping command to ensure that R2's G0/0/1 interface is reachable. Then we have to configure a static route for R2's loopback. One network via R2's G0/0/1 address. First, we are going to ping from R1 to R2's G0/0/1 interface and to make sure that interface is reachable. So let me get the IP address of this R1 IPv4 address. So here we can see G0/0/1. I will copy this IP address. Okay, coming to R1, we will ping to that interface using this address and make sure that you get the replies. Here we can see success rate is 80%. Once ping to that interface using this address. We will remove this space here. I will copy this IP address, or we can give end. Copy run space start. Face loopback 2. We will set the loopbacks 2. That means we borrowed 3 bits from the host portion. So we will get 224. Also, we will set IPv6 address. Loopback. Just we will save it. Now we will configure R2. Here we can see the interface G0/0/0 which is connecting. We can activate it, no shutdown command. IP address. route for R2's loopback 1 network via R2's G0 slash configurations. Yeah, this is very important. Step 1. On R1, configure a static route to R2's loopback 1 network using R2's G0 slash 0 slash 1 address as the next hop address. Use the ping command to ensure that R2's G0 slash 0 slash 1 interface is reachable. Then we have to configure a static route for R2's loopback 1 network via R2's G0 slash 0 slash 1 address. First, we are going to ping from R1 to R2's G0 slash 0 slash 1 interface, and to make sure that the interface is reachable. So let me get the IP address of this, R1 IPv4 address. So here we can see G0 slash 0 slash 1. I will copy this IP address. Okay, coming to R1, we will ping to that interface using this address, and make sure that you get the replies. Here we can see success rate is 80%. Once more, we can try press up arrow from R2's loopback 1. So what is the R2's loopback 1? We can check that from the addressing table. Here we can see R2's loopback 1. Here is the address 10.2.0.1/24. So basically the network address will be 10.2.0.0. So we have to configure that in this R1s. So here we have to give that configure terminal. We will give IP route. So 10.2.0.0. And we have to give a mask dot 0. Okay, then we have to give its next hop address. Already we ping to that 192.168.1.2, correct? So we can copy and paste. Here. Step 2. On R1, configure a static default route via R2's G0 slash 0 slash 0 address. Okay, use the ping command. To ensure 0. Configure this static default route 50%. Once more, we can try R2's G0 slash 0 slash 0 address. That means we have to use the next hop address, the IP address of this interface G0 slash 0 slash 0. So here we have to give this command in R1 conf t. configure terminal IP root 0.0.0.0 space 0.0.0.0 space. Then we have to specify its next hop IP address. We already ping to that next hop address. Here we can see 172.16.1.2. Copy and paste here, then press enter. Coming to step 3, on R1 again. Configure a floating static default route via R2's G0/0/1 address. That means through these switches R1, S1, S2, and R2. Okay, that can be done. We will do that. Coming to R1, and here the specified we must use the IP address of R2's G0/0/1 address. So coming to R1 again, and here we'll give that IP route 0.0.0.0 space 0.0.0.0 space. We have to use that this address IP address of this interface G0/0/1 in this router R2. Already we given that it's 192.168.1.2. Also we have to specify, they told to set the static default route with administrative distance of 80. So here I put a question mark so that we can set the distance metric for this route. So they specify to give 80. We'll give that here. Okay, first we will ping from R2 to this interface G0/0/0 address of this router R1. So its IP address is 172.16. 1.1 we given for this interface G0/0/0. So let me ping that first. Okay, Cisco enable password is class. We will ping to 172.16.1.1 and make sure that you get the replies. Success rate is 100%. It's perfect. Now we can configure a static default route via R1's G0/0/0 address. So coming to R2, configure terminal. We can give a conf-t, and here we will give IP route. Here is the default route, right? With the next hop address, it is 172.16.1.1. Coming to step 5, verify that the routes are operational. Use the show IP route command to ensure that R1's routing table shows the static and the default routes. Okay, we will go to R1 and we will give that show command, exit, and here we will give a show IP route and make sure that these static routes are set. Also, we can see the default static routes. Perfect. On R1, issue the command trace route 10.2.0 The output should perfect. These static routes are set. Also, we can see the default static routes. Perfect. On R1, issue the command trace route 10.2.0 The output should show that the next hop is 192.168. Okay, we will try that. Coming to R1, and here we will give that command trace route. Let me put a question mark. Yeah, trace route, and here we will give the address 10.2.0. Press enter. 1.2. Okay, we will try that. Coming to R1, and here we will give that command trace route. Let me put a question mark. Yeah, trace route, and here we will give the address 10.2.0.1. Press enter. So here we can see it's next hop 192.168.1.2. Yes, it's correct. Now on R1, issue the command trace route 209.165.200.193. The output should 42. Now issue the shutdown command on R1 G0/0/0. Okay, we'll go to
Noel and Kelvin, how's your progress?
Okay.
Where
Un-
are you
un-
now?
until I think I'm at part 3 right now.
Part 3, yeah?
Yeah.
Okay. So this is the static and default routing. How about you, Noel? Where are you now?
Uh,
Part 3 also?
Part 2.
Part 2, okay.
To R1 and we'll shut down that interface. Conf T. We'll go to interface G0/0/0 and shut down it. Okay. First, using show IP route static. End distance of 80. Then demonstrate the floating static route is working by issuing the static and default routing on R1 and R2 practice, but to assess your ability to complete the routers using IPv6. Once again, the static routing being used here is a not mean to present best practice, but to using R1's G0/0/1 address as the next. First of all, we will ping from end PV6 address, so that we can ping from R2 exit and configure this static route for R1. We can so we can give a 10 double colon, right, as a network address /64. Okay, fine. We will go to R2 and we will do that conf t, and here we will configure IPv6 route. We have seen 2001:GB8 ACAD:10, then double colon /64. Then we have to give its IPv6 and next hop address. Already we ping to that 2001:GB8 ACAD:1 double colon 1. So just I will copy and paste here. Then press enter. Coming to step 2 on R2, configure static 2001:GB8 ACAD:1 double colon 1. So just I will copy and paste here. Then press enter. Once the G0 interface is reachable, then we can specify its next hop address and get all through G000, correct? So we already ping to that interface. Let me copy and paste here. Coming to step 3 on R2, again configure a floating static default route retrieve distance of 86 route 001 colon. We can get that from here itself. G001. I will copy this address better so that we can paste it without any mistake. Paste it here and we have to give AD. It's 80 they specify. Coming to step 4 on R1. Configure a static default route via R1's G000 address. So now we are going to configure on R1. Use the ping command to ensure that R2's G000 interface is reachable. Okay, let me get the IPv6 address of that interface G000 here.
Remember your entry go both ways too, huh? So R1 go to via R2, then R2 go via R1, right? When you're doing the static route.
Exit, and we can give IP v6. Show command here to give show IP v6 interface brief. So let me copy the IPv6 address of G000 and we'll ping from R1. Yes, it's working. Configure a static default route via R2's G000 address. It's working. And we'll ping from R1. Exit, and we can give IP v6. Show command here to give show IP v6 interface brief. So let me copy the IPv6 address of G000 and we'll ping from R1. Yes, it's working. Configure a static default route via R2's G000 address. Okay, we will do that. Coming to R1, conf t, and here I have to give IPv6 route /0. Then we have to specify its next hop. Already we ping to that the IPv6 address of G000. Just copy and paste here. Okay. Coming to the last step. Step 5. Verify that the routes are operational. Use the show IPv6 route command to ensure that R2's routing table shows the static and default routes. So coming to R2, we will give that show command here. Show IPv6 routes. So here we can see that default static route. Yeah, perfect. Also we can see the static route to be configured. 1. Okay, we will apply. But here we cannot see any static option. Okay, but the given static option available, but maybe it is available in the real space. I put a question mark again. But here we cannot see any static option. Okay, but the given static option available, but maybe it is available in the real time. Just press enter here so that we can verify it. Here is the static with the AD of 1, and here we can see the default static route with the AD of 80. Yes, perfect. Lastly, demonstrate that the floating static route is working by issuing the trace route 2001:gb8:acad:2009:1 command. And the trace route will show the next hop as the IPv6 address of this interface G001 in this router R1. That IPv6 address is shown here. Perfect. We will check that. Coming to R2, paste that command, and here we can see it's working. 1:1. This is the IPv6 address we set for this interface G001 in this router R1. Perfect. That's all right. So just I will activate this interface. It's activated. Okay, dear friends, in this video we configured IPv4 and IPv6 static and default routes. Now, if you have any doubt or any suggestions,
All right. No, finish already, yeah? Okay, Kelvin?
Almost done. Almost done.
Okay. All right. Any case, our session I think is complete already today. All right. So Kelvin, you want to continue finish? It's okay also. All right. So Noel also already done. So okay. So we can dismiss already for today's
Okay,
session.
thank you.
Okay. All right. Thank you very much. I'll see you guys in our next class. Okay.